So now continuing on, let's take another look at this last one we just did. We had some details that we just went over, but look right here. We have two intercepts, two y-intercepts, one for the upper branch and one for the lower branch of this hyperbola. Let's go ahead and do a little bit of algebra to figure out what those exact locations are. Now, we know that it better be, here's your asymptote, and our equation of that asymptote I had here somewhere. Oh, I wrote it over there. 1/3 x plus 2. Y equals 1/3 x plus 2 for this positive sloped asymptote. We know that that y-intercept on this upper branch better be a little bit above that y-intercept of 2. Okay? So we have a sense of where it should be. Similarly, we should see symmetrically the distance above that 2 to this value. We should see that down here symmetrically below this y-intercept for this negative sloped asymptote. The y-intercept on the lower branch should be symmetrically below that intercept right there. So how do you do the algebra? Well, up here is our equation. And so to find y-intercepts, we do what? We let x take on a 0 value. So let's go ahead and come over here onto the other board, and let's let x equal 0 for this up-down opening hyperbola and find those y-intercepts. So we're going to let x equal 0 in the equation y minus 1 squared over 1 squared minus x plus 3 squared over 3 squared equals 1. And we're going to let this x take on a 0 value. Okay. If we look at this, this is y minus 1 squared over 1 minus 9 over 9. Oh, that's really easy, isn't it? 9 divided by 9 is 1 equals 1. This is a fractional equation. Actually, it's not even fractional anymore because it's just division by 1 here, which actually makes it quite simple. We'll do one a little more complicated in a few minutes. So what we can do then is we can isolate this binomial, and this will be the square root property. So what we're going to do here is we're going to isolate this. Y minus 1 squared equals, we add 1 to both sides and we get 2 over here. And so then we extract the root, solving for y by square rooting both sides. And be careful here, back in beginning algebra, this is plus or minus square root of 2. And then what we're going to do is we're going to move this 1, add 1 to both sides, and we're going to get those two values, 1 plus or minus square root of 2. Now don't just leave it like that. Realize that what you're talking about are the y-intercepts back over there on that graph. So these are actual points. X was 0 up above, and one of them is going to be 1 plus, remember this is y. So we're up on that symmetric line, that transverse, actually in this case it's the conjugate axis line, and we're going to go up above that square root of 2. So there's one of them, and then the other one is x equals 0, 1 take away square root of 2. So back to the picture here, the locations of this upper y-intercept happens to be, this point right here is going to be 0, 1 plus square root of 2. And notice that distance above the 1, here's a height of 1, is a little bit more than 1 because square root of 2 is a little more than 1. And then similarly, you're then going to be up at 1 and you're going to subtract off square root of 2, and that's going to drop it a little bit below this origin. And so this point's at 0, 1 minus square root of 2. So it's real easy. It's actually a pre-college algebra level type of problem where back in the equation you simply let x equal 0. You could also find the x-intercepts by letting y equal 0. And the mathematics would be very similar. Different result. Okay, let's go ahead and do a different problem. And why don't we take a problem where the equation might come to us in a generalized form where we have to build it into a standard form to be able to identify the different parts. So let's pick a problem out of the textbook. And I can go right here. And I'll try to enlarge this so you can see it here. Why don't we look at number 57? 57. 4x squared minus y squared, and then minus 24x minus 4y plus 16 equals 0. Now, you might be tempted, if you're thinking ahead a little bit, to think of this quadratic term in x, positive, and the y term, quadratic, being negative, that this might be a left-right opening type of hyperbola. Well, we actually have to complete the square on both the x variable and the y variable here to be sure that indeed it will turn out to be left and right. We aren't sure yet. It has to do with the fact of what happens with this constant over here after we actually complete the square on both x and y. So let's see what I mean by that. So let's go ahead and take the equation now. We'll put it up on the board, and we'll separate, let's separate the x terms from the y terms. And we'll work this problem completely through. And once we've done this, you should be in pretty good shape on the techniques, or if you follow it okay, you should then be in pretty good shape to be able to handle pretty much any equation that comes at you that would result in one of these hyperbolas. So this happens to be problem 57 in our current textbook, page 671. I'm going to separate the variables as I mentioned. 4x squared minus 24x, followed by the y terms, minus y squared, minus 4y. And then I'm going to take the positive 16, I'm going to go ahead and move it over to the other side of the equation, negative 16, by subtracting 16 from both sides. So there's our equation. If you didn't really understand the standard form that we talked about a few minutes ago, if you didn't really understand that, what you could do is you could simply plot a bunch of points. Now this would be pretty tedious. You'd have to pick numbers, make a table of values with the numbers, different numbers going in for, say, x, and then you'd have quadratic equations in y, and you'd have to solve each one of those equations for the y values. Then you could plot those combinations of points and actually generate the picture. So, much more efficient to have the standard form in mind and be able to complete the square here. So what we need to do, remember this I hope, is you need to have just x squared sitting there. So the best way to do that would be probably factor out the 4 from the x terms. So we factor out the 4 and we're left with x squared minus 6x. Leave some space right there because you're going to have to insert something to complete the square here. Then notice both of these terms happen to be negative. I'm going to factor a negative out and leave a nice y squared there. And this becomes then plus 4y, leave some space, and then equals still the negative 16. So this is still exactly the same equation as we had above. Now we've gone through completing the square in previous sections, previous recorded sessions, and we've also back in college algebra even done that. So what we have to do is we now have it in this structure, this format. We take half of the linear terms coefficient, so half of negative 6 is negative 3, and I suggested before that you write it down and circle it. At the same time, why don't you come over here? Take half of the linear y terms coefficient, 4, half of that is 2, positive 2, including the plus sign, write it down and circle it. Now you have something you can look at so you don't mess up the arithmetic. Square the negative 3, positive 9. Square this and stick it in right here. At the same time, come over here. Positive 2, square it and tuck it in right here. Now look at what you just did to the equation. This is not the same as the original. What we just did, be careful here, we really added 36 to the left side of this equation. So if we do that on the left side, Why don't we do that over on the right side? Let's add 36. Similarly, we just subtracted 4, negative 4 here, from this left side of the equation. So let's subtract 4 over on the right. Okay. Now, the reason I wrote these down and circled them was so that we could see what we were squaring. And then also, this trinomial now is x minus 3 quantity squared. It turns it into a binomial square. Don't forget the 4 out front. Subtracting, similarly here, this trinomial now is tucked down into a y plus 2 binomial square, and that's equal to the number we have on the right, which is taking 20 away from 36 is 16. This is not the standard form illustrated in the previous examples earlier. So what we have to do is turn that into a 1 over here by dividing both sides of the equation by 16. When you divide both sides of the equation by 16, each term, the 4 is going to reduce into 16 and give you a value of 4 underneath here. And that we would write as 2 squared. Subtracting our y plus 2 quantity squared over the 16, which is 4 squared, equals 1. Now we have the standard form from which we can identify the different features of the hyperbola. So indeed, looking back at the original equation, because we saw quadratic in x being positive, quadratic in y being negative, that we were anticipating possibly a left-right opening branches of the hyperbola, and that indeed turned out to be the case here. So it's a left-right opening one, and I oftentimes will write that down, left-right. That's going to help me in choosing where my transverse axis lies and where the vertices lie and where the focus points lie. If the number over here on this arithmetic that we did had turned out to be negative, which it could easily have done, if that turned out to be negative, then when you divided by that number, that would turn this term positive and this one negative, and it would be an up-down opening hyperbola. So you can't really tell which shape it's going to be, left, right, or up, down, until you actually get down to this point. Okay, let's go ahead and continue on with this same problem. Since we've completed the square, let's go ahead and see if we quickly can go ahead and draw a sketch of it and put the detailed features on there. I think we have room right here to do it, if we're careful. So notice that we have a shift which way on the hyperbola? A shift to the right of 3 and a shift down of 2. And then our rectangle, we're going to go to that location, 3 to the right and down 2. There's our center at 3, negative 2. And then our rectangle is going to just go 2 to the left and right. Notice this is associated with the x terms. 2 to the left and right for our rectangle. So over here. And then 2 to the right of that would be over to here. And I'm going to go ahead and label those points. This would be coordinate 5, negative 2. And this would be coordinate 1, negative 2. And then I'm going to go up and down a distance of 4, above and below the center. Up 1, 2, 3, 4, and down 4 from below the center. 1, 2. Just going to make it here. And so now notice that we have a rectangle that is taller than it is wide. There's our fundamental rectangle. Okay, Well, what do we do at this point? Why don't we go ahead and end this segment, and while you folks can pause this or load the next segment up, why don't you go ahead and see if you can go ahead and sketch and calculate the other important features of this.